I'm gonna let the game.
Yes.
Okay.
For what?
April? Yeah.
No, Steve's on the
Oh no,
ground.
it's 41 apparently.
On the ground. Alright,
He's actually
let's
he's good at room checks, right?
I kind of sauced them in your basement. There's nothing that bad.
Oh, I
kind of
Eat
sauced
the
them in your
balls.
basement.
No, stays on the
What?
ground.
I was
I kind of
still looking
sauced
at
them in
that.
your basement.
Sauce too.
Still looking. Yeah.
Oh,
With that.
I didn't know I
you beat him?
You could have done it.
Really?
Oh yeah.
Who's that guy beat you with Depot?
What do I find?
What? Yeah, ties. Sorry.
Said please.
That was a close game though. I gotta say that.
Yeah, it was a tie.
No, I didn't know how to shoot.
I know that.
Were you supposed to hold it?
Yeah. So this is like.
Sam.
That's why you gotta pass it.
That's true. Yeah, pass it.
Well, I obviously know that.
Sam.
You lose.
I don't think so.
I'm a winner.
Okay. I don't know what that's supposed to be.
The man is stronger than gravity.
All right, we'll go through some of the questions you guys had here. We do still have to finish up the rest of the note review, like notes review. I missed it. Oh, it doesn't. I didn't really miss it. It just makes it easy.
Yeah, John.
These are wide. What's up? I didn't play it, so that must mean my one doesn't it?
Yes, sir. I got my 8. I got my 8.
It should make you back and pause.
His hands are like.
It should. That would be a nice update.
Yeah, he's got 4.
He's 4 that end.
Okay. So let's start with number 9 here. So graphing our tangent. So remembering with tangent, so I know going back now, it probably seems like a long time ago. I know like Amy had asked me yesterday, what does the 0 and U's stand for when we talk about tangent? That's like 0 and undefined. Those are kind of our 2 important parts of tangent on a graph. So we talked about with tangent there being asymptotes points. So all the halves are going to be asymptotes. So all the halves are going to be our tangent or our asymptotes, except this one's going to shift over to the left, sorry, pi over 2. But technically, it's just going to put the asymptote backwards, like it's going to like go back on itself. So it's kind of a silly shift in this problem, but because the reason why nothing really impacts it is because the period is just pi. Typically, tangent is pi over b, and b is 1, so it's just pi. Then the other thing to mention, again, the way tangent goes, it goes 0, undefined, 0, undefined, and it keeps repeating that. So that means I'm going to draw my asymptotes in at pi over 2. All the pi's over 2. And again, they would have shifted over pi over 2, and it would just end up in the same spot anyway. And the way it typically goes, it starts at 0. Now, tangent should go uphill, except this one's shifting down 2. So from 0, I should be going down 2. So I put a point there, and then I do my asymptotes. Or not my actual graph. Okay. And we'll review that a little bit more today. You guys will be doing the evens if you didn't do them already, and hopefully get some more practice with that. Again, another thing to do is just even going back and looking at homework, previous homework or previous notes, and trying to practice some of that. Yeah. Go ahead. Did you have any questions or do you have all your, okay, you're good. All right, so number 11 then. So is cosecant, and this one's a strange one because it's tiny because of the units they chose to use, and that might have thrown you off or made you think something was like wrong that you were doing. Oh, and it had this double 4 on it, so hopefully you heard me to say to get rid of one of the 4s, because the double 4 would be a mess. Now cosecant goes with sine. So I'm thinking about sine in terms of this value here. But remember, it's 2 pi over b, so 2 pi over 4, which is pi over 2 is my period. What that means is this sine graph is very small on this graph that they have here. So this is a quickly repeating sine graph, so like really tiny, skinny graph. Now, typically sine starts at 0 and then ends at 0 and it goes to 1 in between there, so typically it goes like this. Whoops, yeah. Now this sine graph is supposed to shift to the left, pi over 2. But again, if it normally should start at 0, it shifts to the left, pi over 2. It's going to end up being at the same spot. So all these shifts have been kind of strange on these questions because they kind of shift back into where they are already. So this should start at 0. It should end at 0. And in the middle, it should be at 0. And then we have to get up and down, up and over, like with our sine graph, in that matter of time. So this just ends up being this tiny little sine graph that will keep repeating. Now remember though, this isn't just a sine graph, this is cosecant. So what I need to do then is I need to take that and I need to draw in my u's. And they're also going to be very skinny because wherever it hits 0, there's like an asymptote there. So we're trying to stay between 2 little vertical lines there. And like again, I'm not going to, oh, I missed one, and I guess 2. I'm not going to like freak out, but if you're drawing ones that look like this, I would hope, I mean, that would be unacceptable versus like if you cross over the line a little bit, that's different. So making sure that it's pretty clear that you're trying to like stay within those bounds. Okay. So then going to number 17, that was one of our multiple choice ones, huh? Yep. All right, so this one's kind of strange because you might look at this and say, I have no idea where anything goes because they don't have any units for me. But you're comparing them to different values. So hopefully that helps you a little bit as you guys are doing this. So the cosine graph, so cosine I know goes like this typically, but this is shifted left pi over 2. Sorry, I was about to write, I said left and I was going to write right. So this is left pi over 2, and it's an amplitude of 1. So that automatically, the amplitude of 1 automatically gets rid of some of these for me. So, like I'm like this whole top row to me, in my opinion, is not going to be it because those two don't even really look like cosine graphs. This one, in my opinion, is probably repeating too quickly. And it didn't shift at all. It started up at 1 and ends back up at 1, so the top row doesn't work. So this one doesn't work because of the amplitude, so I can get rid of that one. So I'm down to a few here. So probably like looking at these, it's probably like between these 4 here, right? So normally cosine, like I have to look at the part of the cosine that I kind of care about here. So this one's not shifted at all, so that one's out. This one looks like it's shifted like 3 spaces over, right? Because it should start at 1, so it looks like 1, 2, 3. Pi over 2 wouldn't be like 3 places over. And in this, like again here, if this is negative pi and this is pi, there's my period of 2 pi's, it shifted 2 over. So it ends up having to be h. So trying to like determine, like kind of break that down, sometimes eliminating some of those by getting some other ones there. And then 23. Shocked you guys asked about 23. You love these. Okay. So I know you guys don't like the ones with months. Again, change months over to like by their numbers. So like right now we're in December, that would be 12. So like January, February, so I'm going to call that 2. And actually the numbers work kind of nicely with months just because we're familiar with the months as numbers. So 12 would be December. So it tells us the highest monthly temperature in Canada is 72 in July. So I need to go up to 72. So I went up by like 5s, essentially. So here's 70 degrees. So in July, it's 72. So I go over to the 7th month, up to 72, and I'm going to put an X just because I don't want to switch my 72, like up there. Then it says the lowest monthly is 44 degrees in January. So 10, 20, 30, 40, 44. Now, since I know that this is supposed to be, we're like using the same curve and it's an average, the next January should also be 44. So I'm going to basically do like a 13th line and make that 44 as well. So I can have my curve going here. So we have to find the midline. So, and I have to find the altitude. There's kind of a lot I have to go, like, figure out here. So I'm trying to find the middle and then how high and low it goes. So high to low, it goes from 44 to 72. So 44 to 72, what is that? Is that 40? 28, right? 28, sorry. And then we're taking half of that, so that'll be 14. So the amplitude's going to be 14. So high to low is going to be 14. So that means 14 above this is going to be our middle line. So 44 plus 14 is going to be 58, I believe should be the middle. So that's the middle here is D, is 58. That's how much we shifted it up from the 0. Now I did the sine graph. If you did cosine, that would also have been okay, but sine, in my opinion, makes sense in this one. This is similar to one we've done before. If you did cosine, it would just have to start up there or start on the other side. So if it's sine, so again, I found D was 58. We have to shift it over from 0 over to this spot, which looks like it's like the 4th month in this one. So this would be right 4. And then the period is from 1 to like 13 to 1. So it actually should, I think I have my period wrong on here. All right, so if I go from 1 to 13, it should be 12, right? I have 13. So 12 months is my period, so I do that as 2 pi over b. So 12b equals 2 pi. So I'm going to divide by 12. So I'd be okay with a period of pi over 6 for my b value. Sorry. So we have enough to write our equation. If we use sine, If you use cosine, your shift will just be different. And then right 4, and then up 58. And then when it asks about March and December, that's just an estimate. So like March, the third month is here, December is here. So I got like 50 and like 40. All right. So if you guys could get out your notes from yesterday, we'll finish those up just to make sure we kind of can review that. I would highly suggest following along with us. The rest of the review will be due along with your note card for tomorrow. Your cheat sheet. Doesn't hurt for us to review some tangent and cotangent. All right, so one of the things with tangent is remembering that the period is pi over b. So again, these are our notes from yesterday. Everyone hopefully should have them. So our b value in this case would be 2. So my period in this case is to be divided in half. What that does with tangent is it divides all our information in half. So normally there's asymptotes at, bless you, pi over 2, 3 pi over 2, 5 pi over 2. However, we're taking half of that, so our asymptotes are now, they happen more frequently. They're going to be at pi over 4, at 3 pi over 4, so I just multiplying the bottom, at 5 pi over 4. So that would tell me that I'm going to do my tangent graph with pi's over 4. That just makes sense in my opinion then. So I'm going up by pi over 4. Pi over 2 would happen next. There'd be a whole pi, 5 pi over 4, so I can get quite a few asymptotes here right away.
What is the first value?
So pi over 4, then it goes pi over 2, so it's 2 pi over 4. Now make sure on the test that you make sure you have everything labeled clearly so I know what you're up to. Just a graph with no labels doesn't really tell me a lot unless you're consistent amongst your whole test, and then I can kind of figure it out. But don't leave me up to have to assume. The graph shifts up 3. So I have to go from 0, I'm going to go up 3. So there's our new graph there. Just to darken those until the green is showing up on the screen. So tangent always goes uphill. That'd be an important thing to write down. Make sure you have that somewhere. Whereas cotangent will go downhill. But all the other same rules kind of are similar enough, but different enough to be confusing. Because now cotangent has asymptotes everywhere tangent doesn't. So cotangent's asymptotes are at the whole values. So at 0, pi, pi over 2, you know, or 3 pi, sorry. However, this one shifted. This one shifted to the right, pi over 2. So normally where it's at 0, it's going to shift over to the pi over 2. So these are all going to move over pi over 2 spaces, whatever you decide that is. Now the 1/2 in the front is just the amplitude, and with cotangent and tangent, that just means the graph, we talked about this before, just means the graph's like curvier. So it's like had more like of a curve to it, it's more of like a skinny line. It's going to be kind of a little lumpier in the middle. So normally asymptoted 0, so I'm going to shift it over. What do you guys do for your units? Do you just want to do pi over 2, or do you, yeah, it doesn't really matter. Pi over 2, here's pi, 3 pi over 2, 2 pi. Okay, so normally it's at 0, so now there's going to be 1 at pi over 2. Normally it's 1 at pi, it's going to be at 3 pi over 2. Now you might say these graphs look so much alike because they kind of are, except that our units are half of what those are. So the units do change kind of our perspective and how it looks. There's one over here, and now cotangent should be going downhill. And so then I think that's all we have left to do. And again, if you don't make it look any curvier, no big deal. Like, I mean, it's hard to draw these as it is, so. You did more spaces, like you used the same spaces as this one, then it would be a lot wider of a looking graph. Okay? And then finally, we're gonna stop with, or start, like finish up with our writing our equation here. And it does say to write it as a cosine graph, so I'll try to help you with that on the word problem. I might even give you guys that clue as to what type of graph to use, just so that we're all working in the same units. Hopefully that's helpful to do that. So for cosine, I usually try to draw where the cosine is that I'm kind of anticipating. Now this one goes from negative 3 pi over 2 to positive 3 pi over 2. So how big is that period? Because technically this is negative 1.5 pi, and this is 1.5 pi. It's 3 pi, yeah. So the period is actually 3 pi in this case. So we're going to have to find our b value. I know finding the b value has been a little bit of a struggle for some of you, so making sure that we're practicing that. So 3 pi equals 2 pi over b. So what the period is, I always set it equal to what the period should equal, which is 2 pi over b in this case, and tangent and cotangent would just be pi over b. We cross multiply. Oops. I'm going to get those pi's out of there because that doesn't help us at all. They cancel anyway. So then we divide by 3. So b ends up being 2/3. Right? Yeah? Okay. You guys have me nervous. All right. Yeah. All right, so we have to find that middle line. So the middle is basically the middle of this graph so that the amplitudes are the same above and below. So this amplitude is 2. You guys keep scaring me. I didn't have a good morning in pre-calc. I like totally messed up the lesson, so I'm like totally paranoid that I'm not.
Well, I've never understood this lesson, so.
All right, so the amplitude is 2. Now, where the midline is located is up 1. So what does that do to our equation? It goes up 1, so that's a whole nother letter. So up 1, so that's D. And then our last thing is our shift left and right. So this one, everything changes. So normally my starting value would be right here. It shifted to the left, or you could even argue shifted to the right. It doesn't matter which way you go. So every once in a while I write plus or minus because either way would work. I shifted it left pi over 3. Or sorry, 3 pi over 2. Sorry, I'm making up things. 3 pi over 2. And so that would be a positive. So finally, when I go to write this equation, my amplitude is 2. It's cosine. My b value is 2/3. I shifted it left pi over 2, so that's a positive. Or sorry, 3 pi over 2. I keep seeing that wrong. Sorry. And then up 1. Did it. Okay.